In this video, we'll be talking about the graphical analysis of average acceleration and the instantaneous acceleration. Let's say we have a graph here. This is the time axis, this is the time axis, and this is the velocity. And the velocity varies as given by this equation here. This is how does the velocity vary. At the starting time, let's say this is the starting time, ti is the initial time. At this point, the starting point, the object started with the velocity vi, and after time tf, the final velocity of the particle is vf. And we need to find out what is the average acceleration between these two times. How do we do that? In order to find the average acceleration between these two times graphically, we just need to connect the initial point and the final point. All right. I'm making it a different color. Okay. So I just connected the initial point and the final point. The initial and the final point. The slope of this line gives the average acceleration. If you just measure the slope of this line, that gives you the average acceleration. And how do we measure the slope of this line? In order to measure the slope, how the slope is defined? It is defined as the rise over run. So in this case, the average acceleration would be this value, the change in the velocity. The final velocity is vf and the initial velocity is vi. So the change in the velocity between these two times is vf minus vi divided by tf minus ti. That gives you the average acceleration. Now, how do I find out the instantaneous acceleration? The instantaneous acceleration, let's say at this point, is if I draw a tangent at this point, I'll just use a different color, this color. So if we draw a tangent at this point, the slope of this tangent gives you the instantaneous acceleration. Similarly, if I draw a tangent at this point, then the slope of these lines gives you the instantaneous acceleration. Okay, so this is how you find the average acceleration and the instantaneous acceleration.